Question number 62. Assume the Earth has a radius of 4,000 miles, and these two cities are on the same longitude. Therefore, one city is due north of the other. Find the distance between the two cities. Okay, so I think you need a picture here to know which direction to head. So if you will, that is Earth, and imagine that you spin Earth in a way such that both of these guys are at the very edge, and they said one is due north of the other. So I can add in my radius of the Earth that they gave to me. Put that in there before I forget about it. And so this can be San Francisco, and this guy up here can be Seattle. And what we're trying to figure out is the distance between these. And it's kind of a neat question because you can't just like use the distance formula. You can't cut through the Earth to get from one city to the next. Really it's really the distance around the Earth because there's some curvature here. So what we're trying to do is we're trying to find the length of part of the arc length. So circumference of a circle is all the way around. Arc length is just part of the way around, and we designate the variable s for that. So it looks like I have r, looks like I have s, and we have a formula that ties all those together. S equals r theta. And so we're on our way. I have the thing I want to solve for. I know this variable. Okay, and then I need to know theta. So that would be the angle in between right here. Well, if I know this is a little more than 47, and I know this is a little more than 37, then the difference between those is going to be what theta is. So now these aren't the same numbers, but just imagine that if this was at 10 degrees and this was at 50 degrees, then the difference between those would be 40. So that kind of helps you see that we just need to subtract those. So I would like to subtract that minus this. And I don't know, maybe your calculator can handle that if you know the correct way to type it in. What I'm going to do is I'm actually going to change each of these from degrees, minutes, and seconds to decimal degrees. Alright, so 47 degrees plus 37 minutes, and a minute is 1/60th of an hour, and 18 seconds. There's 3,600 seconds in an hour. So this is the same as 47.622. 47.622. Okay, approximately. You can see that we could actually keep up with some more decimals. And I'm actually going to store this. If you hit the store button right here, I can store it in for a city, and I'll just call it city B, whatever. And I want to take city B and subtract city A, all of city A, which is 37 degrees, 47 minutes, parentheses around your fractions is always a good idea, and 36 seconds. Okay, so in the end, it looks like the difference between those, if I subtract those two cities, kept up with all the decimals, not rounding here until the very end. Looks like theta is 9.828. Now, I could go ahead and ask my calculator to multiply 9.828 times 4,000, and it will spit out a number to us. And there's probably not going to seem like there's anything wrong with that. I don't think the number is going to be way off or anything like that, but it's not going to be correct. So the whole point of this formula being so early in the year is that we're trying to show you there are some uses for radians. So this formula works only if theta is in radians. Well, right now it's in degrees. So I'm going to convert it to radians. So here's that exact thing again. Convert it to radians by multiplying by pi over 180 degrees. So the degree units cancel out and leaves us with radians. So 9.828 degrees is about 0.172 in radians. But again, I'm keeping up with the exact amount. I've got a calculator here, so it's not any more difficult. And in the end, that is my theta multiplied by my r, and that gives me my s. So it looks like those two cities are 686.147 miles away from each other.